Accurate flight planning requires that you have a thorough understanding of the many types of weather phenomena that may be encountered along your route. The warm front presents its own peculiar problems. Though not as violent as cold frontal weather, warm frontal weather extends over great areas and within it contains very definite hazards to flying. You must know the hazards you'll encounter and where they can be found along any of your planned routes. On surface weather maps, a solid red line depicts a warm front. Let's see how a warm front forms. Due to the frictional drag of the Earth's surface, cold air masses usually retreat slowly, forming a shallow slope. The warm air rides up over the slowly retreating cold air. This flow causes the typical warm frontal cloud structure to develop and extend for hundreds of miles in advance of the front on the surface. Let's examine the cloud structure and the weather produced by a typical warm front. As warmer air glides gently up the frontal surface, layers of stratus clouds will form, followed by a very thick deck of clouds called nimbostratus. Above, but merging with the nimbostratus, another deck of clouds called altostratus forms. Evaporation of the precipitation falling from the bases of these two cloud decks causes lower layers of stratus, stratocumulus, and scud to form. These clouds merge with the nimbostratus deck and may produce a solid cloud layer from near the ground up to the ice crystal cloud layers, which are generally associated with the front. The ice crystal clouds are called cirrostratus. They occur in layers and may merge with the altostratus deck below. On top and ahead of the cirrostratus deck are wispy and plume-shaped cloud patches called cirrus. Cirrus clouds are found as far as 1,000 miles in advance of the front on the surface. Now, let's turn around and come in from the cold air side of the front. Cirrus clouds are your first indication that you are approaching a warm front. They gradually increase in number and eventually merge, forming a thick layer which is the cirrostratus deck. As time goes on, this deck thickens and it may merge with the altostratus deck. As you continue toward the front, the base of the altostratus deck lowers until it merges with the nimbostratus clouds. Precipitation falls from the bases of both the alto and nimbostratus decks, causing scud and stratus clouds to form close to the ground. Close to the front now, the lower scud and stratus merge with prefrontal fog. The net result is often a solid layer of fog and clouds extending from the surface to over 20,000 feet. This band of near-zero ceilings and visibility can be 50 to 100 miles wide and, as shown here in the abstract, could extend for hundreds of miles along the front. Remember, warm frontal weather moves very slowly. If your destination lies anywhere in this frontal area, choose suitable alternates when planning your flight. Now, let's see the weather you will encounter in various parts of the frontal area. The type of precipitation will depend upon the temperature distribution in the warm air above the front and in the cold air under the front. For example, first we'll consider a winter situation. Just above the front, but in the lower altitudes of the warm air, the temperature may be above freezing. In the clouds above the freezing level, snow forms. As the snow falls into the warmer air, it melts, becoming rain or drizzle. The rain and drizzle fall into the retreating cold air under the front and cool rapidly, but do not solidify immediately. Instead, they become supercooled water droplets called freezing rain or drizzle. In this situation, a rapid accumulation of ice will form on an aircraft. Structural ice is hazardous to flight operation, and you should avoid it when possible. When the supercooled droplets have enough time to solidify, they become sleet. In the area where the temperatures in the cold air and the warm air above are both below freezing, snow will fall. For all practical purposes, that is the pattern of weather produced by the warm front during winter. However, many exceptions and variations to the general pattern will be encountered in your experience. This weather map shows a typical warm frontal area again during winter season. We'll use the appropriate symbols to point out the many conditions you'd expect to encounter when your flight path takes you into this area. Between the high-pressure area in the warm air and the high-pressure area in the cold air, the warm front lies in a trough of low pressure. Immediately along the front, the primary weather conditions are scud and prefrontal fog. Usually the warm air has not been lifted enough to cause much precipitation, but occasionally rain and drizzle are found in this area. Further ahead of the front is the portion of nimbostratus cloud layer with temperatures above freezing, which produces rain or drizzle. When this precipitation falls into the cold air below, it changes to freezing rain or freezing drizzle, which becomes structural ice when it strikes your aircraft. Still further ahead of the front, the supercooled water droplets, falling through a thicker layer of cold air, have time to solidify and produce a layer of sleet. In advance of the sleet, and also at higher altitudes, where the temperatures are well below freezing, snow will possibly be the only form of precipitation encountered. However, here's something to remember. Structural ice may be encountered in snow areas when the temperature is not colder than minus 20 degrees centigrade. When a sub-freezing air mass is overridden by warmer air with temperatures below freezing, snow predominates throughout the entire area. This occurs in the northern states. In summer, the temperature difference between the layer of warmer air overriding the layer of colder air is not as great as in winter. In fact, sub-freezing temperatures are rarely found in the lower levels of the cold air masses. However, the cold air above the freezing level may produce snow. The snow falls into the warmer zones below, changing to continuous or intermittent rain and drizzle. Here's the surface map during summer, showing a large dominating warm front. As before, we'll see the weather produced, again using the appropriate symbols. Immediately along the front, there is fog and low clouds, or scud. Though light rain and drizzle might be found at the front, it's not very likely, due to the slow lifting of the warmer air. Precipitation in the form of rain and drizzle falls in a widespread area in advance of the front on the surface. That's the general warm frontal pattern in summer, but there are two notable exceptions. First, and most important, is when the warm air is very moist and becomes unstable. The areas of instability produce embedded thunderstorms in the heavy stratus cloud layers. Though not as violent as cold frontal storms, they can be a menace at low altitudes since they might be encountered unexpectedly. Above the stratus cloud layers, the embedded storms can easily be seen and avoided. When the symbols on the surface weather map indicate showers, thunderstorms, and lightning, the embedded storms should be anticipated in the weather area. The second notable exception in the general pattern of weather with the warm front is when the warm air is very dry. The map then is virtually free of all symbols. Like the cold front, the weather pattern of the warm front varies greatly, depending upon the moisture content and stability in the warm air and the temperature differences between the air masses. Remember, warm frontal weather extends over an area hundreds of miles in advance of the front line on the surface. Typical cloud sequences will be encountered for great distances in advance of the front itself. The surface map, together with the prognostic charts and aviation reports, clearly indicate all of the weather conditions you will experience when your flight planning takes you through a warm frontal zone. Combine the material from the surface weather map, aviation reports, and the prognostic charts with a thorough briefing from the weatherman to be sure you know all the weather associated with the warm front and where it will be encountered. For once you're up there, the question of what to do is strictly up to you.